Lesson 3.13 for review packet 3C. Graph the equation y equals x squared and y equals 3x minus 2. So let's make a table. We have y equals x squared. So we have, let's say we have a table x. You know what I can do? Awesome. Look at this. Technology. Good. Okay. So let's do it. So we have x here and we have y here. No. Let's not do it. We're not supposed to be doing this. Okay, so we have y equals x squared. So let's plug in some numbers. If x is 0, so we'll have 0 squared. So y will be 0. Is that good? That's going to be somewhere over here, right? If we have 1, then it will be 1 squared. So it will be 1 and 1, right? If we have 2, then we have 2 squared. If x is 2, then that will be 2 squared, so that will be 4. Okay? Then you see we have 1, 2, 1 and 2 and 1, 2, 3, 4. Okay? And I want you to do negative 1, negative 2, negative. Well, let me do just one more point. So if it's 3, that's going to be 3 squared, so it's going to be 9. It's going to be 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And I want you to do negative 1, negative 2, negative 3. I want you to plug that in and see what's going to get and then graph the point. We also have to do y equals 3x minus 2. You can plug in any number, but I would try 0. Plug that in here. So 3 times 0 minus 2 will give us, negative 2. Graph that. So we go 0 and 1, 2. That's going to be, let me use the other color. So 1, 2, that's going to be this point. So I use blue for this one. And then you can use another points, for example, 1 and whatever. So you plug 1 here and find out what the y value is, and then graph it. So that's problem number 6. Problem 7, find two equations. So let me just move on. Find the two equations with graphs that intersects at the point negative 5. Show that the point negative 5, 4 makes both equations true. Okay, that's a kind of challenging problem. Problem 7. So we have some kind of graph. Look what I'm going to do. This is awesome. So you don't have to put up with my squiggly coordinate plane. Look at this. Beautiful. Okay. Now we're talking about negative 5, 4. So you go 1, 2, 3, 4, 5. That's negative 5. And then no, I don't want you to do this. Okay, 5. And then you go up 4. 1, no, not 1, 2, 3, 4. So we are talking about this point. And then we have to find the two equations that passes through that line, something like this, or maybe that can be this one. Oh, that's the easy one. We know the horizontal line and vertical line. So what would be this line, right? Let me make it straight. Oh, it looks fancy. And then how about the vertical line of those? That's an easy one. Okay. So find the value, find the equation of this vertical line. What would be the equation of this? And what's the equation of this one? And that's going to be your answer. Problem number 8, standardized test prep. Which point is the intersection of the graphs of y equals 3 and y equals negative 2 x plus 5? I don't want you to actually, for this problem, I don't want you to graph it. I don't want you to be able to find that out. So we are talking about y equals 3 and y y equals negative 2x plus 5. Okay? Then problem A is 0, 3. So you're going to plug the number in there, and if it satisfies, that's if this point passes both tests, this one and this one, then it will be the intersection. So let's just try. Y equals 3 is the same as 0 times x plus y equals 3. So we have 0 times 0, x, which is 0, plus 3 equals 3. Good, it passed the first test. How about the second test? We have y equals negative 2 times x plus 5. So y is 3, and then x is 0. Obviously not, because 3 is not equal to, this is 0, and 0 plus 5 is not 3. So this is not good. How about B? How about C? Okay, that's what you do. Problem number 9. This is the last problem of this packet. Look at the graphs of the equation. Match each graphs with its equation. So, okay, this looks very... So, we got that. And, okay, let's see if I can do... Oh, wait a minute. Okay, so now we have some very fat oval. Let's see how smart this thing is. Ah, there you go. Okay. Ah, beautiful. Alright, so we got that, and then we have another line that passes through this point right there, and then that point. Ooh, beautiful. Okay, so we have that graph, and we have two equations. X squared plus 16y squared equals 25. And also we have y equals 1/4 times x plus 5. Okay? And match each graphs. So right here, this point is actually 0, 1. Okay? But we don't want to use this point because this point will satisfy both equations. So we want to use this point because this point is unique to the oval. This point is 3, 4, 5, 0. All right, 5, 0. You plug in this number. So let's use this 5, 0 to see if this satisfies first equation. If not, this oval is the equation, this one. So we have x squared, which x is 5. So we have 5 squared plus 16 times y squared, which is 0 squared. Is that 25? Yes, it is. So that means this point passed the test of x squared plus 16 times y squared equals 25. Therefore, this equation matches with this graph. So that's part A. Why did I solve this one? You're supposed to solve this one. You're lucky. B, use the graphs to estimate the point where the points intersect. So what would be... So these are the two intersection points. And if these are, this looks like negative 5, 0 as well. But as I said, looks like is not a good reason in mathematics. So what I want you to do is I want you to make sure that this is actually is the intersection point. So you test this point to the first equation and the second equation, and it has to pass both tests to say this is the intersection point. So I want you to do that, and I also want you to test negative 5, 0 and do the same thing, plug in numbers for the first equation and the second equation, and show me that this -5, 0 passes both tests. Okay?